I'd like to take an example. Alright, so that's n cubed over 3 to the n. Now, it's not, the first thing I think of is, can I tell if it's diverging right off the bat? In other words, what happens in the long run? Well, in the long run, can you tell what happens to the terms?
I think
The top numerator outpaces the denominator.
N cubed's bigger than 3 to the n?
I don't know about that.
Yeah, it does. Just
What kind of function is the denominator? Exponential. Exponential outpaces power functions. Okay, so right thought, right approach, just a little backward, right? So the denominator is going to get much bigger, so the terms are going to get close to 0, which is actually a bummer. Because if the terms didn't get close to 0, I could say it diverges. But since they are getting close to 0, I can say nothing. It's not geometric, so I'm out of luck with that. Right, exactly. Because if it's geometric, I'm home free. Not only can I tell if it converges or diverges, if it converges, I can tell you what it converges to. I do not want to integrate that.
how do you tell what it converges to?
With a geometric series?
A over 1 on the side.
Oh yeah.
Right, it's great. It's great. Geometric is great.
A over 1 minus.
You know what I didn't do yesterday? Or last night? I didn't give you some of the error problems. I should have given you a couple with error. Emily's fine that I didn't. I do want to tell you this, and if I said it yesterday, I apologize. This is just what adults do. They repeat things over and over again, thinking that's the first time they said it. Perhaps you're familiar with this from such people as your mom or dad or your grandparents. I put a couple videos online. Did I tell you this already?
Doesn't sound.
I put a couple videos online, and they're awesome. As some of you may know, I'm taking that course, like sort of auditing an online course that Penn's offering, and the professor is just brilliant and has put together some very great 15-minute videos. So it's not like they go on and on forever. And I posted 2 that are all of the convergence tests that we've done, and I think he does them in a very succinct and informative way. And he like rates them. He said, this one's really useful. This one's really easy to use. So if you have some extra time. Say again?
What's the class for?
So I'm taking it because I am trying to pilot what online courses look like. I'm trying to look at how do you offer a math class online? Like, what does that mean? What does it look like? And obviously, delivering content is one thing, but assessing understanding is a different thing, and that's a hard thing to do, I think, online. So that's what I'm doing. And this guy's, he's great. Okay, so I'm not going to integrate that. That's a polynomial or a power function and divided by, right, an exponential. No way, right? Comparison test, it's not jumping out to me. I don't see what I'm going to compare it to.
Like, isn't that a type of function where like n is like greater than 1?
Well,
Comparison test is the hardest.
So 1 over 3 to the n would be a geometric, which would converge, but this is going to be bigger than 1 over 3 to the n because the numerator is n cubed. So bigger than a convergence doesn't help. So I don't see a clever one to pick. And there might be one. And I do want to say this. Oftentimes with series, there's more than one way to approach it. And you might have a more clever way than I do. You might say, well, why didn't you just do this? I'll be like, you're absolutely right. Did I already say it's not alternating? It's not alternating. So that's a bummer. So I have a new strategy for you. And it's a great strategy because it's fairly easy to use. All right? And the strategy hinges upon looking at the limit. Was that a yawn? Was that a, oh no?
Sorry,
No, it's fine.
It
was-
Look at me.
It's okay. It's like 2:45 at the end of the day. So looking at the limit of what happens to the ratio of the terms. So I'm going to do it, and I'm going to tell you. I'm going to show it, and then I'll explain, and maybe it'll click, and you're like, oh, all right. So
Could
here's,
you do L'Hopital's rule to see if it approaches 0? Oh, as n goes to infinity?
so you can, but remember, if it approaches 0, I don't know anything.
Yeah.
So it's sort of a bummer, right? And as a matter of fact, I don't need L'Hopital's rule. I can look at this and tell that the denominator gets bigger much faster.
You're
Right.
gonna put a box around this or should
I'll give you a box in a little bit. You don't need a box now. I would definitely watch, and if you want to, you can write it down. But so here's what I'm going to do. I'm going to look at the limit absolute value, because I don't want things like alternating series to get in the way here. I'm going to look at the limit of the n plus 1 term to the nth term. So in other words, in the long run, I want to know what's the ratio of the next term to the term right before it. And I'm going to say it, I'm going to explain it, then I'm going to do it, then I'm going to say it again. Here's the theory. If we can show that this ratio is less than 1, not for the first 2 terms, not for the first 10 terms, but in the long run, if I can show you that the ratio is less than 1, that means that this series behaves a lot like a geometric series in the long run. And if this behaves like a geometric series with a ratio less than 1, it converges. If in the long run, the ratio of these terms, the term in front of it to the term before it, is greater than 1, that means in the long run this behaves a lot like a geometric series with r greater than 1, and it's going to diverge. So the idea is a geometric series has the same ratio. Every term has the same r value. It's always like, 1/2 as much as the one before it. That's not true here, but if I can show you in the long run that we get close to the same ratio, that means, hey, we're in luck.
Is
All
that a to the n plus 1 or a sub n plus 1?
A sub n plus 1, right? So down below, this is saying the n plus 1th term over the nth term. So here's what it looks like. The n plus 1 term is n plus 1 cubed over 3 to the n plus 1. The nth term is n cubed over 3 to the n. Well, that certainly doesn't look like it made anything easier. Well, it is. It's going to be okay. Is that okay for just how I plug things in?
Yes.
Okay. So I'm going to write it as n plus 1 cubed over 3 to the n plus 1. Now, instead of dividing, I'm going to multiply by the reciprocal. Okay. 3 to the n over n cubed. Can you tell me anything about?
You can factor this. Yes.
We-
So there would be an extra 3 on the denominator.
Yeah.
It's like, yeah,
So I could subtract exponents and I get 3 to the negative 1, or I could cancel them and get a 3 in the denominator. But either way, this is going to end up being 1/3. Is that okay? All right. So I'm left with 1/3 times n plus 1 to the 3rd over n to the 3rd.
Yeah.
But I can write that as, right, yeah, everything n plus 1 over n, the whole thing cubed. And when n gets huge, what happens to n plus 1 over n?
It's
like almost 1.
Like 1,000,001 over 1,000,000?
Yes,
A
it's about
gajillion and 1
1.
over, it's about 1.
Yeah.
And 1 cubed is 1. So this whole thing goes to 1, and I'm left with 1/3. Now, that's not what this converges to. 1/3 is what the ratio of the terms end up being. And because the ratio of the terms end up being 1/3, that means that this guy behaves a lot like a geometric series, where r is 1/3. And if r is less than 1, absolute value of r is less than 1, it converges. So this series converges because of the ratio test. Because the ratio test says, hey, if the ratio in the long run is between 0 and 1, you have a converging series. If the ratio in the long run is greater than 1, you have a diverging series.
here.
Hmm?
So we have infinity to the 3rd, and then 3 infinity to the 3rd.
I have
So-
1/3,
Right.
right? And then I have, if you want to think about a really large number over a really large number, the same, almost the identical large number. So if you have a gajillion over a gajillion,
Okay.
that's 1, right?
Right.
Are You could do L'Hopital's rule as one of them.
Yeah, you could, right? You want to try another one out?
Yeah, I guess we can't find out what it converges to.
Right. We don't. So we still haven't we haven't cracked that nut. Right. We haven't found out what it converges to, but we can tell that it converges. Oh boy. All right. Interesting. Back to doing that again. Huh.
You didn't do it in a while.
I know. It's because I had it plugged in behind. I gotta figure everything out again. Okay. So let's see. Now, I think I know that you know the answer, but I want you to use the new ratio test. I think that you think that I know you know the answer, but I want you to do the new ratio test for both of these. All right, so do a quick little ratio.
So, back question. With the thing where if it's like, does it have to be is it less than equal to 1, or is it just less than
Interesting, you should ask.
1? This is the first one.
First.
So for a geometric ratio,
Yeah.
for a geometric series, it has to be less than 1. Otherwise, it would be like 1 plus 1 plus 1 plus 1 plus 1, and that just keeps getting bigger. Now, this is interesting, though, because tell me,
Because that's
what did you get for the limit here?
Well, that's almost 1, but that one you
The
know
limit is 0, but 0.
The
I'm
limit
not-
is 1.
It's
Yeah,
1.
Oh.
The limit there is 1.
But if it's less than or equal to 1, that would say that it converges, but we know
No, we
that.
don't. It's less than 1. Just
Right,
no
so
numbers.
the-
it has to be less than
Well, so I actually haven't formally stated the ratio test, and I've been holding off because I wanted you to do these two. So if it's equal to 1, you know that this. What about this one?
I haven't done that one.
Let's do this one.
We know that P is
Same
greater than
thing.
1 there, so we know
But
that
that's like the
should
same thing.
converge.
And it converges to 1.
N squared over n squared plus 1. So the limit is equal to 1, but we know that the series, this is a P series, right? This P series
Oh, right.
converges. So this is the drawback of the ratio test. That if the ratio of the terms is
So
equal to
if it's
1,
then you don't know anything.
it's inconclusive. It tells you nothing. It doesn't tell you, hey, it might
has to
do
be
this.
Less than 1 to converge, and it has to be greater than 1 to diverge,
Yep.
or it can do both when it's equal to 1.
Right. So when it's equal to 1, what it tells you is,
What
hey,
you do when it's
you picked the wrong test. That's what it tells you. All right. As a matter of fact, we were silly to have picked the ratio test for these. You know, this is the harmonic series. That's a P series. We know just by looking whether these converge or diverge. Okay.
Should it
Yeah.
Did I mess up?
should the n plus 1 quantity too? Or
Oh yeah, you're right. Sorry.
it doesn't change?
It doesn't, but you're absolutely right. That's my fault. Sorry about that. So, I think you're ready. For those of you who are interested, thinks my finger is okay. So, here's the ratio test in a box. You don't need to write it down, but you can write it down if you want. Know that it's in your book. All right. So,
give us a sheet with it all.
I think it's actually in that summary. The summary that you initially had, probably in a much more concise way.
This thing?
What? Yeah. Isn't it there down at the bottom?
That's exactly.
So, okay. So if the limit in the long run is less than 1, then we know the series converges. Now, this is interesting. There's this term absolutely convergent. Part of the lesson in the book talks about the difference between absolute and conditional convergence. We're not talking about absolute and conditional convergence, okay? You can know that it exists, but the and what it means, absolute convergence means that it converges for the absolute value of that series. Some very interesting mathematical things happen for series that conditionally converge. We're not interested in those interested things, at least today, right? Probably not this year, maybe next year you'll be interested. All right, if the limit is greater than 1, the series diverges. Oh, and tonight's homework, the book directions say determine whether the series absolutely or conditionally converges. But if you read my assignment from the assignment sheet, it says only say whether it converges or diverges. I don't need you to tell me if it's absolute or conditional
Thank you.
convergence. Sure, well, it only makes sense, right? I haven't told you much about it, so go ahead.
What was it? You said absolute.
Or conditional convergence. So I'll give you an example of something that converges conditionally.
Sound of this.
Additionally,
That's basically saying if something is true.
So the alternating harmonic series converges conditionally because if you alternate the signs, it converges. But if you take the absolute value,
But then
it doesn't converge. So
So-
we call that a conditional convergence.
but we're not worrying about that.
We're not. We're not. But the question was asked, so I couldn't refuse answering. Actually, sometimes I can. Try not to. All right. And this is Emily's like corollary, right? 3 is like, hey, if the limit's equal to 1, it tells us nothing. Completely inconclusive. And I will tell you this up front. Oftentimes, if you try to use the ratio test with p-series or something that you could use the integral test with, you're going to get something that's inconclusive. Okay, the ratio test is a really bad test for things that you could notice using like a p-series test.
I find the comparison test to be really difficult,
It's challenging.
especially when they're disguised.
If you know what to compare it to, it's a piece of cake. If you don't know what to compare it to, it's
The issue
terribly
with all
frustrating.
This, though, is that like if it doesn't fit like, the exact specifications, you know absolutely nothing.
It's true. It's hard. It's really hard.
Please
So
Yeah.
there's
take that
no
into account
way
Yeah,
when you write
27.
the test.
Everything.
No.
Let me give you one more to practice a little.
That's very true.
You gotta do the test.
You missed it?
That we failed. I think you should have to take that grade.
No. That's not fair.
All right. So this is n to the n over n factorial. Because I've been around series a little longer than you have, this is screaming the ratio test. Because everything else that you can think of, like it's not geometric, we don't even know how to integrate factorials, like what does that even mean? I have no idea what to compare it to. So this is screaming ratio test because
I don't even know how to write n factorial as anything other than n factorial.
Well, because if you plug in 1, then it's 1 factorial. If you plug in 2, then it's 2 factorial. If you plug
Yeah,
in
but there's
3,
no way to
it's
write that in
factorial.
terms of n.
n times n minus 1 times n minus 2 times n minus 3, right?
Okay.
All right. So go ahead, take this for a spin, take a couple minutes, try out the ratio test, looking at the term n plus 1 and looking at the term when can't even talk. Looking at the nth term and looking at the n plus 1th term. And remember, the ratio test doesn't tell you what it converges to. It's just going to tell you if it does converge or does not converge. know how to cancel some of these things.
The bottom one, the first one, and the top
Could be
one.
1 over n.
Is that n to the n?
Yeah.
Because that's almost 1, isn't it?
So
Should that be 1 over n?
Oh, that's n to the n.
did I mess something up?
Or 1 to the n. 1 over n plus 1.
Did I mess something up, or I need to? All right, all right. So n factorial is n times n minus 1 dot 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 dot. N plus 1 factorial is n plus 1 times n minus 1. So do you see how everything's going to cancel here?
Should it just be n factorial?
It's almost 1.
No, it's not. It's 1 over
Wouldn't
n.
it be n factorial?
I totally forget how factorials work.
Right.
Hey,
So, right, n factorial is thinking, hey, I'm n times n minus 1 times n minus 2 times n minus 3. N plus 1 factorial is thinking, hey, I'm n plus 1. What's the term before n plus 1?
n.
N times n minus 1 times n minus 2. So do you see how you're going to be left with 1 over n plus 1? Alright, so I have n plus 1 to the n plus 1, and then I have 1 over n to the n. Is anything, I think, I have the same base here.
Yeah.
So you can correct.
And I think you're just going to be left with n plus 1 to the nth.
Okay, n plus 1 minus 1, so it's just n.
Huh. So this is n plus 1 over n to the nth. Does that convert? Is that greater than 1 or less than 1?
n plus 1 over n.
Is that?
Why isn't it
No,
not?
That's
It's
1.
A little greater than 1.
It's a little bigger than 1,
Yeah.
As opposed to infinity. Just
raising it to something huge.
Why isn't it 1 over 1 over n plus 1 times?
So it's very close
N
to
to the
You're
1.
not stop. We're like on here.
Before you take the nth, it's something, it's very, very close to 1.
Okay.
But if you raise it to something massive, then that
It gets
little
bigger.
imperfection is going to get bigger and bigger.
I don't think so. I think it's
No,
gonna
if you
get
raise
closer
it
to 1.
Alright.
enormously, it would be 1, I think.
Well, I have a question for you. Do you think it's bigger than 1 or less than 1? Or equal to 1?
Probably
That's
bigger.
slightly larger.
Yeah.
Does everyone agree it's bigger than 1?
Yeah.
Alright, so it diverges. We know it. Now, I have a follow-up question. There's nothing to do with this problem. Right, so, first things first. This is bigger than 1, so that series diverges. Hold on. I have a follow-up question. Has nothing to do with the problem. What is this equal to?
I don't think.
Well, I'm going to rewrite it just a little bit. I'm going to write n over n as 1, and I'll write 1 over n as, and I guess, whoops, what we're doing is we're looking at the limit as n approaches infinity. So get out your calculator. Try some values for me.
So you're at. Wait, we see them. Why is that looking?
Say again?
Well, that's just 1 plus something really, really, really small.
Right. I'm just rewriting the same thing, right? So what happens when we have 1 plus a 10th raised to the 10th? Come on.
You mean 2. Oh, yeah.
1 plus a 10th, right? Raised to the 10th.
1.
You can't do that in your head. Stop. 1 plus a 100th raised to the 100th. What do you get? Start talking to me. What happens if n is 10?
Approaches 0.
What do you get? 1.1 raised to the 10th.
1.0001.
Yeah.
Really?
It's gonna get closer to 1.
1.1 raised to the 10th? Is it really 1.0001?
No, it's 1. It's 1. The limit is 1. No, wait. What?
It's
That's
2.59.
Thanks. I don't understand. Hold on. Stop for a second.
Yes.
Stop. I'm asking you to do something, and one of you is doing it.
1.1 to the 10.
Yeah.
That's 2.59.
Great. That's 2.59. So my next question is, what if n is 100? What's 1 plus 100th raised to the 100th?
Something big. Or is it small?
I don't know. I'm asking you.
2.7.
2.7 what?
0.
Great. What if we do 1,000?
Just equals
bigger.
3.
What's 1 plus 1,000th raised to the 1,000th? Raised to the 1,000.
2.71.
2.7183 is our
Two point-
final limit.
All right.
Using the calculator, sending like what?
What is that number?
now.
Isn't that like E?
It's
That's
E.
what I've seen.
Oh,
I feel
magic.
like I've seen that.
That's E. And I'm sure
Well,
Mr. Wotus defined it for you, but if you want to think about this, E is the limit as you take smaller and smaller compounds and compound them more and more times, right? So if you're compounding something, no, but right, one,
that
Mind
where
not
it comes
comprehending.
from? Is
Mind
that what
can't
Yeah.
go 'cause it can't
developed?
comprehend.
absolutely.
So like pi is like the ratio between the diameter of the strings or whatever, and that's
And
what
this
that
is the limit. E is this limit, all right?
I
It's
don't
a
understand the
growth
explanation.
limit. You don't remember doing compounded interest?
Not really.
So if you compound something annually,
Mr. Wotus said
stop please. If you compound something annually, you take that and raise it to the first. If you compound it monthly, you take the amount, divide by 12, because you're getting it every month, and raise it to the 12th. If you compound it daily, it's 1 plus 1 over 365 raised to the 365th. So this is the ratio of what, the limit of what happens as you continue compounding. This has nothing to do with the problem. All this tells us is, hey, this limit's E, it's bigger than 1. All we care about is it's bigger than 1, right? It's bigger than 1, the series diverges. But, interesting, right? Very interesting. All right, fine.
You chose that on purpose.
Go ahead.
Oh
That's a
boy.
crazy
Alright,
problem.
well, to start off with, I got n plus 1 to the n over n to the n times n plus 1.
Okay, I did.
So where could I have possibly, like, when I crossed out the factorials, where could I have possibly gone wrong there?
So when you cross out the factorials, you should definitely have an n plus 1 in the denominator, right?
Yes.
All right, so that's what these reduce to. They reduce to n plus 1 in the denominator. Okay? And now we have n plus 1 to the n plus 1 over n plus 1. So I can take that and I can subtract the exponents because n plus 1 is really just n plus 1 to the first. So if I take those and subtract n exponents, I'm left with n plus 1 to the n. These all reduce to n plus 1 to the n. And I still have this n to the n that I haven't done anything with in the denominator. Okay?
I'll work this out.
All right. All right. Or you can go back and look at the screencast because it's there forever. Forever. You can probably like scroll to minute, 23.
Including you telling me to hush.
Yep, that's gonna be a
Might be true.
I'm gonna go back just for that.
All right, let's see. Nope, still thinks my finger is something that's not